Okay, welcome to 5.4 notes, and we're going to start off with a median of a triangle is a segment from a vertex to the midpoint of the opposite side. So what that means is a median, well, like the definition literally says, it starts at the vertex and it goes to the midpoint of the opposite side. So it goes to the opposite side, but not just anywhere, okay? So that would be wrong. It has to go to the midpoint, the middle of the opposite side, okay? So it bisects the other side. So really the way that you construct a median is you have to find the midpoint of this side, okay? Once you've found the midpoint, either through a construction or measuring or folding the paper in half, all those different techniques that we went over. Once you find the midpoint, then it's a very simple matter of then taking a line segment from that midpoint and popping it over, didn't want to do that, hold on, popping it over to the vertex, okay? So that's what a median is. You need to know the definition of a median because we're going to be constructing three medians of a triangle and seeing if they have a point of concurrency. So, are the medians of a triangle concurrent? Okay, that's our question. And you try. Why don't you do the three medians of a triangle? So you would take the midpoint of every side and then connect it to the vertex that's opposite that midpoint and see if you come up with a point of concurrency. In the other lectures, I've had step one. I had you draw, or construct, say for example, a perpendicular bisector. Step two, the next perpendicular bisector. Step three, the third one. But in this case, I think you're kind of good at it. So why don't you just, if you need to, you could turn off or pause the presentation and create the three medians right now. And so I'll just move on at this point. But again, you could have paused it, or you could pause it at any time, of course. And so I have another median. So this is, again, the midpoint of one side, and it connects to the vertex opposite it. And then we're going to do one more. It's going to be the third median, and that goes again from the midpoint of that third side to the vertex opposite that. And so the question is there a point of concurrency? Do three medians of a triangle meet at a point of concurrency? Well, do they meet? Yes, they do, right there. They meet at that point right there, and that point of concurrency is called a centroid. So we have, yes, the medians of a triangle meet at a point of concurrency. That point of concurrency has a special name. Okay, three medians make a centroid. So we have a centroid. And the centroid of a triangle divides the medians in the ratio 2:1, such that the distance from the centroid to the vertex is twice as long as the distance from the centroid to the midpoint of that median. So in other words, the distance from the centroid to the vertex is going to be twice as long as the distance from the centroid to the midpoint of that median, that distance. So in other words, if this was 8 inches, for example, then this would be 4 inches. Okay? You can pause this, review it if you need to. And put another way, the centroid will always be 2/3 of the way along any given median with the longest segment nearest the vertex. So this follows from the previous statement about the distance from the centroid to the vertex being 2, or twice as long as the distance from the centroid to the midpoint of that median. So this just follows from that. It's just another way of saying it. Okay, that the 2/3 of the way along any given median with the longest segment nearest the vertex. So in other words, it's saying that this portion will be 2/3 of the whole entire thing, 2/3 of this whole entire thing, and this then, of course, follows that this would be the remaining 1/3. Okay? And so what I did here to make it a little bit easier to see is I took the same triangle, but I just got rid of the other medians, and I just have the one median up there, and I took away all the tick marks, just so we can get a simpler version of what's going on. So I have that BP, which is the distance from the, it's the longest segment nearest the vertex, that's BP, the longest segment nearest the vertex, right? See, it's nearest the vertex, is going to be 2/3 of the whole distance, of the whole BF, okay? And again, then it follows then that this distance must be 1/3 of the whole entire distance, which again would be BF, okay? And also, as we said on the previous frame, BP is going to be twice as long as FP, okay? And the same is true for the other two medians. So in this case, AP is going to be 2/3 of the whole entire distance, and AP is going to be twice EP. So the same thing is true for that median and for the third median. In this case, CP is going to be 2/3 of the whole entire distance, CD, and CP is twice DP. Okay, what is another interesting feature of the centroid of a triangle? So what you can try to do now is cut out a triangle and make sure that you cut it out of a firm, like a cardboard or something firm like that, and try to lay the pencil, or rather the triangle, flat on the eraser end of a pencil. So in other words, try to balance the triangle laying flat on top of the eraser end of a pencil. Okay, so you can try balancing a triangle. You can pause this presentation right now and try that on your own. But for the sake of this presentation, I'm going to continue. And what you should have discovered is that the centroid is the center of gravity, or the center of mass, of the triangle. It's the point at which the triangle can balance or lay flat on a pencil. So again, if P is the centroid, it's also the center of mass or the center of gravity of that triangle. And we will talk more about what, there's some interesting features of the center of gravity of an object in general, or of a triangle in particular. But that's more of a physics application, and we'll just talk about that more in class. It's something kind of fun. Right now, I'd like to introduce you to some types of problems that you might get regarding the centroid. So we have this triangle where P is the centroid, and if SC equals 21, then our job is to find PS and PC. So let's start with PC. PC is equal to 2/3 of SC. Remember, the distance from the centroid to the vertex is equal to 2/3 of the whole distance of the whole entire median. So we have PC is equal to 2/3 of SC, and SC is given as 21. So 2/3 of 21, 21 divided by 3 is 7, 7 times 2 is 14. So PC is 14. So if PC is 14, remember, if this distance is 14, then the other part we already went over is half that distance, so it must be 7. It must be 7. So let me get rid of that for a second. And so now let's find PS. And ignore, hold on here for a little bit. Sorry about that. Ignore this for a little bit. I don't know why that came up. But anyway, so let's be concerned about this part. So 2PS is equal to PC, and we know that PS then is 1/2 of PC, and we know that PC is 14 from right here. So PS is half that, and that's where we get the 7. Okay, so PS is 7 and PC is 14. Okay, now problem 2. If BT equals 10, find TC and BC.